Hello class, as you may have noticed from some of our recent worksheets, we have already started to talk about what we call isotopic notation, and you see an example of that right here on your screen. We are talking about the symbols used to determine the number of neutrons in an atom. Remember, isotope. Go ahead and put that down here. Remember, that means that the same type of atom has a varying number of neutrons. And you're looking at the isotopic notation of a uranium atom. And let me review this quickly because we will do some more practices with it, and I will tell you up front, we will do this on the test. So I'd like to go ahead and make it so only the symbol and the numbers show. Now remember, with isotopic notation, we see two types of numbers. The top number is the mass of the atom, and that is the mass number. And in this case, we're looking at the number 238. Remember what mass number means. It is the number of protons plus neutrons that occur in the nucleus of the atom. On the bottom number, we see the atom's atomic number. And in this case, that number is 92. Remember, the very definition of the atomic number is the number of protons that appear in the atom's nucleus. So now that we've reviewed the two numbers that appear in the notation, let's answer some questions about this isotopic notation. First question may be, tell me the atom's mass, the mass number or the atomic mass of the atom. We're looking at the 238 on top and the 92 on bottom. We notice that the atomic mass is the 238 right there. Or I could have referred to it as the mass number. Remember, the main difference is one of these gets the unit AMU. Will that be mass number or will that be atomic mass? That will be the atomic mass. It gets AMU. But the top number, mass number, if I ask for the atom's mass from this notation, you would say 238. Now I want to know how many protons this atom has. Well, remember, we said a few minutes ago that the bottom number is the atomic number, so this atom of uranium will have 92 protons. A little bit messy drawing, but 92 protons. Now, the last thing about this particular part, clear the screen, I want to know the number of neutrons that the atom has. I want to know the number of neutrons in an atom of uranium that has a mass of 238. And we said this in the notes before, we would simply call this uranium-238. Ran out of screen there, but the hyphen would tell me uranium-238. The total mass is 238. Now remember, we have protons plus neutrons up top. We have protons only on bottom. So for me to get the total number of neutrons, I'm simply going to do this. Subtract these two. Once again, protons plus neutrons. This is the number of protons only. And if I subtract and look at it carefully, it's already set up like an elementary school type of subtraction problem. I will get the number that I'm looking for. And that will be the number of neutrons that this atom of uranium-238 would have in its nucleus. So, let's just subtract like we're in elementary school. 8 minus 2 is 6, and 23 minus 9 is 14. So this uranium-238 atom has 146 neutrons in its nucleus. If I add the 92 protons, I get a total of 238 atomic mass units, or the mass number of 238. Let me set up another one, and I want you to give it a try. So here is an atom of silver. We would call this silver 108. And we would do that because we know the mass number right here is 108. So I would call this silver 108. Okay, let me clear off the screen. I want to know a few things about this atom. I want to know the atom's mass. I want to know the number of protons that it has. And I want to know the number of neutrons that this atom has. I'll pause a moment to let you figure out these three. The mass is the top number, 108. Remember, that's protons plus neutrons. The atomic number is the number of protons, so that answer is 47. If I want to figure out the neutrons, I simply subtract, and I end up with 61, which is my number of neutrons. And that is the isotopic notation for an atom of silver that has a total mass of 108 AMUs. We'd call it silver 108. Okay, one more thing and we'll be done with this particular lesson. So I have a sentence here that tells me to write the isotopic notation for an atom that has 76 protons and 114 neutrons. I look at my periodic table and I remember that the number of protons is the atomic number. So the 76 protons right here tells me that I have an atom of OS, which is osmium. And remember also that the atomic number goes right down here on the bottom. Now, this atom also has 114 neutrons, but I don't put 114 at the top. Remember, that's the total mass. I will simply add these two together right here, because now I'm going backwards on what I did a little while ago. 4 plus 6 is 10, and I just do, again, some elementary school math. 7, 8, 9, I get 190, and that is the mass of this osmium atom. So right here I see the isotopic notation for an atom of osmium that has a total mass of 190 because of the 76 protons and the 114 neutrons. That's all there is to isotopic notation. We will do plenty of practice examples in class. I look forward to working with you and seeing you then. Good night.